Alright then, so yesterday we had the new definition of allotropes. That is substances of the same element that have different physical properties but the same chemical properties. So, we talked about the diamonds yesterday, and today is the graphite. Okay, so graphite and diamonds are allotropes because both of them contains only carbon. So, in graphite, the carbon atoms are covalently bonded to 3 other carbons. Right? In diamonds, we had 4. And as you can see from the periodic table, that means carbon is in group 14. We see it can make 4 bonds. That means it has 4 valence electrons. Okay. So they covalently bond to 3 other carbons to form a layer of 6-sided rings, which we can see here. So if we look at this carbon, for example, it's bonded to 1, 2, 3 other carbons. Okay, so we have 4 valence electrons for each carbon, and it's only bonded to 3 other carbons. So what happens to our fourth valence electron? Okay, our electron will be free as it was in metal bonding. So these layers, as you can see, there are layers of our carbon rings, right? Okay, so in between these layers, they are cross-linked by weak van der Waals forces. Okay? Let me just go back to the yellow highlighter. Okay. So, some of the electrons in these rings are delocalized. What does delocalized mean? Yes, so it's going somewhere else other than the original carbon atom it comes from. So they are free to move around. Okay, this makes graphite the only non-metal to conduct electricity. So, if you connect a battery to the lead in your pencil, it will conduct electricity, but do not do that, right? Because the lead will explode because it's not pure graphite. Okay, so it will hurt, okay? So your pencil lead, the lead in your mechanical pencil or just your normal pencil is a mixture of graphite and clay, right? So there is clay inside, that's why it will explode if you connect a battery to it. Okay. Last example we have is quartz sand. These are silicon oxide, right? SiO2. And they are covalently bonded to form a hard crystal lattice, okay, with a melting point of 1610 degrees Celsius. So it's not important for you guys to know what these melting points are. It's just to tell you they are extremely strongly bonded, so it's very difficult to break these bonds. Okay, so because it is such a hard substance, okay, this quartz sand is used as the abrasive on sandpaper. You guys know what sandpaper is? Yes, so what is on the sandpaper is quartz sand, silicon oxide. Now, as we can see, they tell us it forms a crystal lattice. We said a crystal lattice. Okay, it's done now. You guys are talking the whole time and it's really irritating. Okay. So it is a pattern that is followed in our crystal structure, right? So we had the crystal structure that looks like this, right? Where it's like a sodium ion, a chloride ion, a sodium ion, a chloride ion, a sodium, chloride, and so forth, okay? So this is silicon oxide's pattern. So we start with the silicon, we get it bonded to an oxygen, then we have the other silicon. And then we are bonded to 3 of the oxygen atoms, and each of those oxygen atoms is once again bonded to 3 other silicons. So we form this pattern the whole time. that we can see, right? So this is what quartz sand looks like. Okay, now on to our final type of bond, chemical bond, and that is ionic bonding. So ionic bonding happens between metals and non-metals. So in the covalent bonds, we saw they shared the electrons, their orbitals overlapped, and they share the electrons between them. With ionic bonding, this is not the case. Our metal will give its electrons to the non-metal. Okay? So this is what the definition says. It's the transfer of electrons to form cations and anions. So our positive and our negative ions. We will see this now because we're going to draw Lewis structures for them as well. An ion is a charged particle that is made from an atom by the loss or gain of electrons, right? We know this by now. Okay? If we have an ion, okay, it is a charged particle because our atom either lost or gained electrons. So metals like to lose their electrons and non-metals like to get electrons. You were also at life sciences. Okay, so an anion or a negative ion is a charged particle made from an atom by the gain of electrons. No problem. So an ion, negative ion, it gained electrons. Okay, our example here, what would form a negative ion? Yes, I'm recording. Okay. So, for example, if we look at nitrogen. Nitrogen is in group number what? 16. Okay, and now what is the charge that will form on a nitrogen? -3. It's the thing at the top there. -3 is the charge that will form. So does that mean it lost or gained some electrons? It gained. So we have +3 electrons on the left hand side, and this gives us a nitrogen ion with a charge of -3. Okay, you can also write it as nitrogen -3 or 3 negative. Right, so a cation is a positive ion. So that is made by losing or gaining electrons. Okay, so we lose electrons to form a cation. So if we take magnesium for example, remember our metals like to lose their electrons. So if we look at magnesium, what is the charge that will form on a magnesium ion? +2. Okay, so we lost electrons, right? So we will write this on the right hand side. We would write the 2 electrons, right? Okay, do you guys understand why we write the electrons on the one side for our anions and other side for our cations? All of you, do you understand? Okay, so if we look at the anion, for example, it's like baking a cake. We have flour and we add eggs to make our cake, right? For a cation, we use the analogy of an egg, right? So we have our egg here, then we break open the egg to use it to make our cake, and then we have the innards of the egg, the yolk and the white of the egg, and the shell. Okay, so we break it apart. Okay, it loses the electrons afterwards. Okay, so during ionic bonding, one or more electrons are transferred from from the metal to the non-metal. Okay? So our metals give their electrons to the non-metals. So our metal loses electrons and forms a positive ion, and the non-metal that gains electrons forms the negative ion. Okay? You need to remember metals like to lose their electrons while non-metals like to gain their electrons. So now we have a positive ion and a negative ion. What do we know about things that are positively charged and things that are negatively charged? They attract each other, and that is where our ionic bonding comes from. The positive and negative ions attract each other electrostatically using our Coulomb forces. Okay, positive and negative stuff. And this forms our ionic bond. That's why it's called ionic bonds, because ions need to form for an ionic bond to exist. Okay, so these positive and negative ions pack together to form a crystal structure. Okay, so positive and negative ions pack together to form a crystal structure that consists of thousands of ions. Okay, there is a lot of atoms in a tablespoon of salt. Okay, the formula of an ionic compound, okay, only gives the simplest ratio in which the ions occur in a crystal structure. So for example, if we have our sodium chloride crystal or salt, that means our structure kind of looks like this. So for each n amount of sodium atoms, there is an n amount of chlorine atoms. That means if we have 100 sodium atoms, we will have 100 chlorine atoms. So we use this ratio, right, to write our simplest formula, okay, with this simplest ratio. So we have a 1-to-1 ratio. For each sodium atom, there's a chlorine atom. That's how we end up with our formula that looks like this. Sodium chloride. For each 1 sodium, there are 1 chloride atoms. Okay, and a few properties of our ionic compounds. They are solids with high melting and boiling points. Okay. They are also called salts. So, for example, potassium permanganate, okay, if we have this, okay, this is also a salt. So when we talk about salts in the future, we are not only talking about table salt. Okay, it's just to show you, we call ionic bonded molecules, or now I can't remember the word, we call them salts. Okay, and they are hard and brittle. They also do not conduct electricity, only when they are in their molten state. What does molten state means? Liquid. So yes, when it has been heated to melt, or they are dissolved in water, can our ions move freely and conduct electricity. Right, that makes sense, because we have positive stuff and negative stuff, and now they are free to move about if they are in solution. For example, if you dissolve table salt in water, now the ions are free to move. Okay, then if you connect a battery to that salt water, it will conduct electricity, because electricity, right, is just charges that move. Okay, yes.
But why does electricity in water?
Okay, so that has to do with the polarity of water. We already drew the the water's Lewis structure. So because this is angular and because oxygen has a larger electronegativity, our oxygen will become slightly positively charged, no, negatively charged, and our hydrogens will become slightly positive. Okay, so this is just in the atoms itself. Okay, so it's a what we call a dipole, but this is grade 11 work, and that is still why you shock. Okay, it's because of the polarity of water.
So salt water and a better neutral.
Salt water and?
A better neutral.
No, it will still shock you because it can conduct the electricity. And also remember the water that we drink, the water you find in your swimming pool. The ocean is obviously salt water, but the water in a lake, it's not only water molecules, right? There's other stuff in there too. It's like the minerals they tell you need to take in every day. So that is what we find in our drinking water. So it's not only water. Okay, so that is what mostly I believe will conduct the electricity. Okay, so almost there, almost at the end, guys. Okay, so an ionic solution that will conduct electricity. So if we dissolve a salt in water, that is called an electrolyte. Okay, this will also be work that you do in grade 11. Is figuring out what happens when you put two electrodes connected to a battery in an ionic solution. That ionic solution is called an electrolyte. So we can also represent ionic bonds with our Lewis structures. Okay. In these representations, the number of electrons given off by the metal must equal to the number of electrons gained by the non-metal atoms. That makes sense, right? We can't have sodium giving off 1 electron and our chlorine molecule gaining 2 electrons, right? We can't do that. Okay? What the one atom gives off, the other atom must gain. That's what this last sentence says. Okay, so now let's draw some Lewis structures. Okay, so we have sodium chloride. So we have sodium and chlorine. Sodium has how many valence electrons? 1. Group number 1, so it has 1 valence electron. Chlorine has, how many does chlorine have? 7. 1, 2, 3, 4, 5, 6, 7. So, according to our rules, our metal, sodium, will give off its electron to our chlorine. Okay, now this will be written a little bit differently as you are used to. So our sodium electron loss, our sodium atom lost an electron, so it forms an ion. What charge will be on our sodium ion? Just positive 1, right? Because it lost 1 electron. Right? And then we write our negative ion in square brackets. Okay, because this is an ionic bond. So chlorine will have the 7 electrons, his 7 valence electrons, and the electron he got from sodium. Now our chlorine gained 1 extra electron, so there would be a negative charge on it, right? So we write the negative charge on the outside.
Remember, there's two types of different Lewis structures.
Yes. Okay. So in the exam, you will be asked, draw the Lewis structure of this compound. Then they will give you a compound. And you must decide whether to draw it like this or to draw it where they share the electrons, because you must know whether they are covalently bonded or ionically bonded.
But if you draw it like this, when you say bond
Yes, okay, so if you draw it wrong, right, if it must be a covalent bond and you draw it like this, it will be wrong. But it's easy to remember. A covalent bond forms between non-metals and non-metals, and an ionic bond forms between non-metals and a metal. Okay, so next one is calcium oxide. We have calcium and oxygen. Calcium has how many valence electrons? Calcium? 2. It is in group number 2. And then oxygen has how many? 6, because it is in group 16. Okay, so this will give us a ionic bond. So we have calcium that lost the 2 valence electrons, so it forms a 2 plus or a +2 ion. And then we have oxygen with all the electrons it had before, plus the 2 it gained from the calcium atom. Yes?
For the valence electrons, didn't you say we must minus the from the previous number guess?
Yes, I did. Okay, so I'll explain it now. So oxygen gained 2 extra electrons, so it forms a -2 charge. So that works for our first 3 groups, but because we have only space to draw 8 valence electrons, we are working with what we call the octet rule. Okay, but that you will learn later. So the first 3 periods up until element number 20, you can use the rule where you minus the previous noble gases atomic number. But for anything below that, so we'll have an example with bromine and iodine. We look at the group number. This is group number 17, so it has 7 valence electrons. Group number 16 has 6 valence electrons. Yes.
So if I use that method with what we've been
Well, just like group 14 has 4 valences. No, it's completely correct. So, okay. So it's just to show you, yes.
I can still use the valences like groups number 17 and like 7 electrons with the any of the first 20 elements.
Yes. Okay. So let's continue. We have. Okay, so when you do this in the exam, right, your marks will be all given for this. Okay, we draw this so that you know how to draw this at the end. Because if you didn't draw this, for example, for water, right, if you didn't draw this, you might have not have known that the paired electrons are both next to each other. Okay, and that your molecule must be angular. Right. So, no, it is not needed for the plus in the middle. It is still better to actually draw it, so let me draw it in, but it is not completely necessary. So we have magnesium, that's a terrible M, magnesium and chloride. So we have 2 chloride atoms. So magnesium has how many valence electrons? 2. 1, 2. Chlorine? 7. Group number 17. So 1, 2, 3, 4, 5, 6, 7. And the same will be for the one at the bottom. Okay, so now we see each of our chlorines is missing 1 electron, right? And magnesium has 2 electrons. So 1 electron will go here and the other one will go to the other chlorine atom. So first of all, we have our magnesium. It lost 2 electrons, so it forms a +2 charge. We put our negative ion in brackets So we have our chlorine ion with the 1, 2, 3, 4, 5, 6, 7, and the 8th electron it got from magnesium. So first of all, what is the charge on that chlorine atom? It got 1 electron extra. So it's just negative, right? Okay, but we have 2 of them. So for the same way we write our chemical formula with the 2 here at the bottom in the subscript position, we write a 2 here on the outside of our brackets to show that there are 2 of our chlorine ions.
Ma'am, will they be dot marks if you wrote your 2 next to the negative?
Yes. Okay. Because the chlorine atoms have a charge of -1, even though we lost 2 electrons from our magnesium. This 2 shows us that this whole bracket thing, that there are 2 of them. Okay, and then we have 2 negatives to balance out with the positive 2 here. Yes?
The metals are always going to lose electrons and the non-metals are going to gain.
Yes. Okay, you can see that when we look at the charges on the periodic table, right? All of our metals up until group 13, 14 have a positive charge, and all the non-metals above our steps will have a negative charge. Okay, next we have aluminium fluoride. There's 2 ways we can draw this. So we have aluminium and our 3 fluoride atoms. Aluminium has 3, thank you. 1, 2, 3. And fluoride has 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Oh, I'm drawing this wrong. 1, 2, 3, 4, 5, 6, 7. So each fluorine is going to gain 1 electron from the same aluminium atom. So we get aluminium. It lost all 3 valence electrons, so the charge will be positive 3. Then we have our fluorine atom with all the electrons now. Only 1 fluorine atom gained 1 electron, so the charge will be negative. And the 3 at the bottom to show that there is 3 of our fluorine atoms, or ions, now that they have bonded.
At the top of that fluorine bracket, you don't have to write the number of electrons it gained. You just write
No. Okay, right? Because each fluorine atom gained 1 electron. So each fluorine atom has a negative charge. Okay? So this part of the bracket is showing us what 1 fluorine atom looks like. Okay, and what the charge on our 1 fluorine atom is. Then this 3 down here tells us there are 3 of these fluorine atoms. Okay. The other way we can draw this is to write aluminium with the 3 electrons, and we add 1 fluorine. Okay, and then we show, oh wait, I forgot something. Okay, so we plus 3 of our fluorine atoms, and then all 3 of the electrons go here. Then we have our arrow with just the same end product as in the previous one. Just let me draw it like this. Not with the highlighter. All right. You guys good? Okay. How do you guys feel about the Lewis structures? Okay. Okay, so now we're just going to go to our last page. This is the last thing we're doing this term. is our relative formula mass. Okay, do you guys remember what our relative atomic mass is? Okay, that's when we have isotopes, right? Okay, and we have a certain percentage that isotopes appears in nature. We use those percentages, right, to calculate the relative atomic mass. But now we have the relative formula mass, MR. Okay, so if we have a bond like this, we have sodium sulfate, right? Let us just highlight here before I forget. So from the formula, the relative formula mass of a compound can be calculated by adding the relative atomic masses together. So if you look on your periodic tables, not the periodic table up there, right, we have sodium. And sodium's relative atomic mass is what? Relative atomic mass, not electronegativity. 23, okay. So we have sodium here, Na, with a relative atomic mass of 23. But we have 2 sodium atoms, so we have to multiply that 23 with 2. Then we have sulfur. Sulfur's relative atomic mass is 32, so it's this 32 over here that we add to the sodium's mass. Okay, and then lastly we have our oxygen. Oxygen's relative atomic mass? 16 over here. And lastly we have 4 oxygens. So we multiply it with 4 to get our answer of 146. So 146 is our relative formula mass for sodium sulfate. Yes.
The 32, what is it for?
That's this 32. It's for the sulfur. It's the relative atomic mass for sulfur.
4 times 16 is for the
Yes, 16 because it's the atomic mass of our oxygen. 4 times because there are 4 oxygens. Right, next we have the mass of calcium nitrate. Okay, so what is calcium's relative atomic mass? 40. Right, then we start with nitrogen, okay? But there are brackets here. So what do? We put brackets. Okay, let's hope that's enough space. Then inside we have sodium, not sodium, nitrogen. Nitrogen's relative atomic mass is 14. And then we have 3 oxygens. So 3 oxygens. So we have 3 times 16. Alright. But now on the outside of our brackets in our chemical formula we have a 2. Right, so this whole bracket we must multiply with 2. Okay, so let's just, this 2 comes from there, and our brackets come from the brackets over here. Okay, this is going to give us a final answer of 164 atomic mass units. Or just, yeah, atomic mass units. Okay, so next up we have copper sulfate and it's hydrated. So we can see there's a dot here and we have 5 waters, right? You can understand that. No?
Yes.
Okay. So let's start with the copper sulfate. Copper's molar mass?
64.
63,5. We don't round off with the numbers we get from the periodic table.
Then
Okay, let's just continue with this one quickly so we can finish it and you can do this exercise for homework. So we have sulfur next with an atomic mass of 32. Then we have our 4 oxygens. So we have 4 times 16. And lastly, this dot tells us we need to add. No. Okay, because this just says for each copper sulfate atom, there are 5 waters around it. Okay, so we add. This dot means plus. Okay, so we have 5 times 2 waters. Hydrogens, relative atomic mass is 1. And we have 1 oxygen, which atomic mass is 16, and this is going to give us an answer of 249,5 atomic mass units. All right, so I want you guys to go do this exercise, right, and the homework on page number 8. Okay, so we can quickly go through it tomorrow before we play the Kahoot game. And just remember with these ones, okay, so now we get the name sodium chloride, or let's talk about ammonium nitrate. Ammonium and nitrate are found on your cation and anion tables, and each of them have a charge, right? So you must be able to go write NH4 with its charge, I think it's just a positive charge, plus your NO3 with a negative charge to get your formula. All right, I'll see you guys tomorrow then. And on the 28th, the day